The title of the STEM project is Interactive Periodic Table.
Theory.
A periodic table is an arrangement of chemical elements in the form of rows and columns. First proposed by Dmitry Mendeleev in the late 19th century, it has since been science's most significant achievements. The periodic table classifies elements into three categories: metals, non-metals, and metalloids. Metals are generally lustrous, malleable, ductile, and are good conductors of heat and electricity. Non-metals, on the other hand, are bad conductors of heat and electricity and are generally dull, non-malleable, and non-ductile. Metalloids are those substances which have properties of both metal and non-metal.
Objective. With the increase of interactive learning methods, this project is creating an interactive periodic table that aims to revolutionize the way we view and understand the periodic table. The standard periodic table provides no interactive properties, but this project has developed a fully interactive periodic table using HTML, CSS, and JavaScript. Methodology. Creating an interactive website requires extensive knowledge of web development, that is, HTML, CSS, and JavaScript. In my version of an interactive periodic table, I use HTML, CSS, and SCSS, and JavaScript. If one wants to create such an interactive website, they must have knowledge and experience in such markup/styling/programming languages. To gather data and information about all 118 elements, I use MySQL, a database management system, while others can use DBMS such as SQLite, MongoDB, and PostgreSQL. Findings. The periodic table not only represents the standard representation of the elements, but also allows the user to interact with them and study the elements. When an element is clicked, the user can view all of the necessary information about the element. Additionally, the user can learn more about the element by clicking the Know More button, which will redirect them to a Wikipedia page of the respective element. By incorporating interactive properties and functionalities such as clickable groups, clickable elements, users can get detailed information about elements. This promotes active learning and enables users to broaden their knowledge of the periodic table and its applications. Conclusion.
In conclusion, an interactive periodic table provides a visual representation of the features of any periodic table.
The title of the STEM project work is Interactive Periodic Table, Lanthanide and Actinide Series. Theory. A periodic table is a tabular arrangement of chemical elements based on their atomic number, electronic configuration, and their similar characteristics. A periodic table is systematic and helps scientists know more about each element better, hence helping in research. This project is about lanthanide and actinides. Lanthanides consist of 15 elements starting from 57 lanthanum to 71 lutetium. Actinides have 15 elements as well, starting from 89 actinium to 103 lawrencium. These elements are inner transition metals, and most of them are radioactive elements. Objectives. The main objective of this project has been to create an informative and interactive periodic table of lanthanides and actinides. The interactive periodic table is also meant to make learning more fun, as it can help improve one's ability to understand elements better by studying it at a more visually appealing manner. Methodology. An interactive periodic table can be made using different languages like HTML, CSS, JavaScript, etc. Here, HTML is used for making the web page and its content. CSS is used for styling the web page, and with the help of JavaScript, it is possible to make the table interactive. Findings. Through the help of this project, it is able to showcase the elements of lanthanides and actinides in the periodic table with their unique traits such as their radioactivity, use, characteristics, and much more. This project also helps with learning programming languages and, in general, creating different web pages with different functionalities. Conclusion. In conclusion, lanthanide and actinide series can be studied and examined in greater detail and clarity by developing an interactive periodic table.
The topic of the STEM project work is Interactive Periodic Table, Alkali Metals. Theory. The modern periodic table was constructed by Henry Moseley in 1913. It consists of 118 elements that are classified into rows and columns according to the increasing atomic number. The alkali metals are classified into group 1A, and it consists of lithium, sodium, potassium, rubidium, cesium, and francium. The elements of this group are highly reactive as they have only one valence electron. They fall under the S block, and Some of the elements of this group are really difficult to obtain as their half-life is very short. Objectives. The main objective of this project was learning how to integrate math, science, and programming, as well as learning about different characteristics of the properties of the alkali metals. Methodologies. HTML, CSS, and JavaScript were used to make this interactive periodic table. Here, HTML was used to make the web page, and CSS was used to make the web page more attractive. I used JavaScript to make the web page and the periodic table more interactive. JavaScript was also used to make the dynamic electronic configuration of the alkali metals. Findings. The homepage contains information about modern periodic table, Mendeleev's periodic table, and the alkali metals. The navbar and the heading contains links to the respective interactive periodic tables. The modern and Mendeleev's interactive periodic table displays information about the respective elements, and the web page containing the alkali metals displays the electronic configuration of the element. When you click on the electronic configuration, the information about the respective element is displayed. Conclusion. After the completion of this project, we can verify that an interactive periodic table can make the study of different classes of periodic table easier.